Hello, we're going to find the inverse of this and then prove that it's symmetrical to the line y equals x by verifying it back from the inverse and f of composite functions. We'll get to that. So first we're going to go y equals and then 2x plus 1 over x plus 3. I'm just going to keep this rolling here. And then we're going to change our letters to find our inverse. This problem will get fairly intense as we go here. Plus, just going to make that slightly smaller. There we go. All right, so now we got to solve this for y. Cross multiplying is definitely our best bet here. So we're going to put that over 1 and cross multiply. So that will be, so we multiply like this and like that, we will get 2y plus 1. And x times that, of course, would be x times x plus 3 like that. So we would distribute, that would be yx plus 3x. And I'm going to write it just like that. So xy plus 3x. Now we're going to solve this for y. So we're going to take this and throw it over here, and then we're going to take the plus 1 and put it over here. Okay, so we're going to do, that is going to become 2y minus xy equals 3x minus 1. All right, then we factor out a y. We need to get it y by itself, so we factor out the y, and that would be 2 minus x. Now, if I reordered that, it would be negative x plus 2, and that would be okay. I'm just going to go ahead and leave the leading term at 2. It's fine. So equals 3x minus 1. And then if we divide both sides by 2 minus x, that'll cancel right there, and y will equal 3x minus 1 over 2 minus x. And that would be the inverse of x. So now, if that was all you were asked to find, that would be the end of that, but we have to verify. So we have to do two different things here. First one would be f of f to the negative 1 of x, and then we're going to have to do the other one. So let's go ahead and work on that. This is probably well, both of these are going to be gross, so this is going to take a little time here. We'll start off by writing this, and we'll put parentheses, so it's going to be 2 big parenthesis plus 1 over big parenthesis plus 3. And that's 2x plus 1 over x plus 3. And I'm going to put this into this function right here. So that's going to be 3x, I should have made my parenthesis bigger, minus 1 over 2 minus x. That's going to go here and here. All right, so I'm going to go this way with that. On the top, now I have to take the 2 times this fraction. So when I do that, I just distribute it through the top. That is the easiest way to do that. So that's going to be 6x minus 2 over 2 minus x. Now I'm going to go ahead and continue this step here so I don't have to keep rewriting this over and over. Plus 1, and I need to get a denominator of 2 minus x. So the way I'm going to get a 1 out of that is to make the top the same thing. That is 1, right? That's 1. So that's the same as that. Alrighty then. So this bottom one, I don't have any number here to multiply it by, so I'm just going to carry that over. 3x minus 1 over 2 minus x plus, now, 3. So remember, that's 3 over 1. And to get a common denominator, in other words, to make this bottom 2 minus x, I have to multiply the bottom by 2 minus x and the top by 2 minus x, like that. And so that's going to become 6 minus 3x. Gotta make sure, one little mistake and this whole thing is for nothing. Okay, so now I will try to put that right here. So here's my line. On top, I'm going to get something over 2 minus x, and that something is going to be 6x minus 2 plus 2 minus x. That looks like, if you wrote that all out, that would be 5x. 6x minus x is 5x. Negative 2 plus 2 is 0. That's correct. On bottom, it would be 2 minus x. And on the top, the 3x's would actually cancel. So 3x minus 3x would be nothing. Negative 1 plus 6 would be 5. And we are good to go. This problem right here is now a division problem. And we're one step away from being done with that. So what that means is this divided by this. So that's 5x over 2 minus x divided by 5 over 2 minus x. So you recopy the first, change the sign to a times. Let's actually use a dot so we don't get x's all jacked up. This gets flipped over, and it becomes 2 minus x over 5. Of course, those will cancel. That 5 and that 5 would cancel, and everything else is 1s, so that's just 1x. Right? And that's what's supposed to happen. So if we do, that's one way. Now you got to turn around and do it the other way. F to the negative 1 of f of x. Right? And it's the same sort of drill, except this time we're starting with this one, and we're plugging this thing inside of it. Okay, so we say 3 big parenthesis minus 1, I'm just copying this, right? That's what that is, over 2 minus big parenthesis. Now, inside of that, it's going to go our original function right here, our original. So that is going to be 2x plus 1 over x plus 3. I'm telling you right now, this problem isn't as bad as number 24 in our book, because on that one we had minus signs here. And that makes things a lot more difficult. This should be 2x plus 1 over x plus 3. So let's see if we can get this to work out. We are going to have to navigate these negative signs. So that is going to be a little bit more difficult. So I'm going to distribute the 3 through there. And again, I'll go this way with it. That's an arrowhead right there. So that, here's my big line. That would be 6x plus 3 over x plus 3. Now, people often ask, why don't I multiply the bottom by 3 as well? Well, think about it. If you do that, you're multiplying by 1, not 3. If you multiply the top by 3 and the bottom by 3, that's 3 over 3, which is 1, and that doesn't change it. You need to triple the top and not the bottom, right? So minus, now, the bottom is x plus 3, so we need to make the top x plus 3, but I'm going to put parentheses right there because of this minus sign. Because when I do that top piece, I'm going to have to change both of these signs, like I'm distributing a negative 1 through it. All right, let's worry about the bottom now. So I have a 2. So I'm going to have to that's 2 over 1. I'm going to have to multiply it by x plus 3 and x plus 3 like that. And when I'm going to get there, I'm going to have to take the 2 and distribute it. So that would be 2x plus 6. At any point, if you get lost while you're watching this, just back it up. That's all you got to do. It's real simple. Just back it up and keep working at it. Do it again. Minus x plus 3, and then this would be 2x plus 1. But again, parentheses on purpose there because this is a minus. So I'm going to be taking that away. Now I'm going to come over here. All right, just to save some real estate. Let me pull that down just a little bit. All right, so we have on top. So here's my line. On the top, I have x minus 3 on the bottom, and then it's going to be, let's see, 6x minus 1x. So I tell you, if I rewrote that, let me rewrite it right here. It would be 6x plus 3 minus x minus 3. That's what that becomes right there. All right? So that would be 5x, just 5x, that's it. On the bottom, something over x plus 3. I find it helpful. I've been doing this forever, and I still write this out. I really would if I were you too. If I write this piece out right here with that minus sign, now if it's pluses, I just go for it. But if it's minus, I don't really trust myself to get this in my head. That would be minus 1, and then I look at it, 2x and 2x, those cancel, and so I would just be left with 5. And you can see that that is very close to the exact same thing I had before. This is just going to be 5x over x plus 3 divided by 5 over x plus 3. Flip it, rewrite the first, change the sign to a times sign, flip the fraction over, reciprocate x plus 3 over 5, and then cancel. That whole thing cancels that whole thing, that 5 cancels that 5, and we are left with x. There you go. That is how you do that. That is not over any of your heads, and you just need to practice that. Have a great one.